This is part 53 of ASP.NET Core tutorial. In this video, we'll discuss how to upload a file in ASP.NET Core MVC with an example. Here is what we want to do. On our Create Employee form, we want to include a field for photo. Using this file upload control, the user will be able to select a photo that he wants to upload onto the server. When this form is submitted, we want to store employee name, email, department, and the photo path in the underlying employees table, but the photo itself should be uploaded onto the server into this images folder. If we take a look at our create view, at the moment the model for this view is our employee class, but we are not going to use this employee class as the model. We are going to create a view model that is specific to this create view. We'll understand the reason for that in just a bit, but first, to this view models folder, let's add a new class file. Name the file employee create view model. The properties in this class are going to be very similar to what we already have in our employee class. So let's copy over and then change the bits that are required. At the moment, we don't need this ID property in our view model class, so let's get rid of that first, and then let's bring in the required namespace for these validation attributes. dept enum is present in employee management.models namespace, so let's bring that in as well. Here is the important bit to understand. Let's change the name of this property from photo path to just photo, and the data type of this is iFormFile. This type is in Microsoft.ASP.NET Core.HTTP namespace, so let's bring that namespace in. If you're wondering why did we set the data type of the photo property within our view model class to iFormFile, well, that's because the file that is uploaded to the server can be accessed through model binding using this interface iFormFile. As you can see, this iFormFile interface has got a lot of useful properties like content type, headers, length, file name, and then a few other methods. We're not going to use all these properties and methods. We're just going to use the file name property and then this copy to method to copy the photo into the images folder on our web server. Now, coming back to the question, why did we create a separate view model for our create view? Well, that's because to be able to access the uploaded file on the server through model binding, we need a property with this type, iFormFile. At this point, you could argue we could easily do that on this employee class as well. Just change the data type of this photo path property to iFormFile. Well, if we do that, we have to create a navigation property because iFormFile is a complex object, and creating a navigation property could complicate things further. On top of that, we don't want to store all this information about the uploaded file in the underlying database. We just want to store the name of the file in the underlying employees table. So to keep things simple and take this example quickly forward, we have set the data type of the photo path property to string on the employee model class, and this class corresponds to the employees table. And then on this view model class for our create view, we have included photo property with this type iFormFile, so we could receive the uploaded file on the server and access it through model binding. At the moment, the model for our create view is still employee. Let's change this to our new type, employee create view model. We don't need this employee repository injected into our create view anymore, so let's delete that. And we also don't need this code right here, so let's delete this as well. At the moment, on our create employee form, we only have fields to capture employee name, email, and department. We also need a field to be able to upload employee photo. It's going to be similar to one of these fields, so let's copy the email field HTML and then change the bits that are required. The label here is for photo property within our view model class, so let's change the property name here to photo. Even on the input element, we want to change this from email to photo. This placeholder attribute is not required. To style this file upload control properly, in addition to form control bootstrap CSS class, we also need custom file input class. We are not performing any validation, so let's delete this span element. We need a label, and for styling, let's use custom file label bootstrap class. We want the text choose file in the file upload control. Again, for proper styling, let's wrap the input element and the label with a div element, and then use the bootstrap class custom file. To support file upload using this form, we have to set the form element enc_type attribute to multipart/form data. At this point, let's save our changes and take a look at the browser. Notice when I reload this page, we have the file upload control as expected. Now, one question you might have at this point is, nowhere in the HTML we have specified that we want an input element whose type is file. When we set the input element type to file, then we get the file upload control. Here, we have not specified that we want an input element whose type is file. But how did we get this file upload element? Well, that's because on the input element, we have set ASP-for tag helper to the photo property. And if you look at the photo property, its data type is iForm file. So ASP.NET Core knows if the data type of the property to which we are binding is iForm file, then it has to provide us with file upload control. And that's how we got this file upload control. Now, if we inspect the page source, notice the input element type is set to file. At the moment, we have a small issue with the file upload control. Notice when I select a file to upload, notice we don't see the file that we have just selected. But when I hover the mouse over, that's when I see from the tooltip we have selected a file with name david.png, but the file upload control itself does not display that selected file. To fix this, we have to write a couple of lines of custom jQuery code. Now, if we take a look at our layout view, notice we have a custom section here called scripts. We're going to use this section to inject the JavaScript that we need. So in our create view, just before the closing form tag, let's include a section. The name of the section is scripts. We want to write some JavaScript code, so let's include the script element, and when the document is ready, we want to execute some JavaScript code. What we are writing here is jQuery code. If you are new to jQuery, I suggest please check out our jQuery course. It starts from the basics and covers all the concepts you need. In the interest of time, I'm going to paste the required jQuery code and quickly walk you through. The first thing that we are doing here is selecting the HTML element that has the class custom file input. We're using the jQuery class selector here. This is going to select our file upload control because this is the input element that has the class custom file input. Once we have the file upload control selected, we are binding to its change event. Whenever the text in the file upload control changes, we want this code to be executed. So when a file is selected, its text changes and this code will be executed. And the line right here selects the name of the file that we have selected in the file upload control. So once we have the file name, we want to display that file name using this label that is present next to the file upload control. So to select this label, we are again using the jQuery class selector. So select the element that has this class custom file label, and this is the label that has that class, and then we are displaying the file name using that label. Let's save these changes and take a look at the browser. Notice now when we select a file, we see the selected file in the file upload control. When we submit this form by clicking the create button within our home controller, this is the create action method that handles the posted form. Now if we take a look at our create view, notice the model for this view is employee create view model. So within our home controller for this create action method, let's change the parameter type to employee create view model, and let's name this parameter model. If the model state is valid, the first thing that I'm going to do here is create a variable of type string. Let's call it unique file name, and then initialize this to null. On the incoming model object, whose type is employee create view model, we have a property photo, and this property receives the uploaded file. So we want to check if the photo property on the model object is not null. If the photo property is not null, that means the user has selected a file to upload, and we want to upload that file to the images folder in www.root folder. To get the physical path of this www.root folder, we are going to use iHosting environment service provided by ASP.NET Core. So let's inject iHosting environment service into the home controller using its constructor. Let's bring in the required namespace and name this parameter hosting environment. And let's use Visual Studio to generate the private field. On this iHosting environment service, we have web root path property. This provides us the absolute physical path of this www.root folder. Remember, we want to upload the file to the images folder. So to get to the images folder, we want to combine the path string of this www.root folder with this images folder. For that, let's use the path class. This class is present in system.io namespace. Let's bring in the namespace and then use combine method to combine the path string of www.root folder with the string images to get to the images folder. Notice from the IntelliSense, the combine method returns the path to the images folder as a string. So let's store it in a variable of type string. I'm going to name this variable uploads folder. We want the file names in the images folder to be unique. If we upload two files with the same name, one file may overwrite the other. We don't want that to happen. To ensure we have unique file names, I'm going to use GUID class. GUID stands for Global Unique Identifier. Every time we call this new GUID method, it returns a new GUID which is guaranteed to be unique. Let's convert this to a string. To this, let's append an underscore. And to that, we want to append the uploaded file name. To get to the uploaded file name, we use the incoming model object. On that, we have the photo property, and on that, we have file name property. Let's store this unique name in this variable. At this point, we have the path to the uploads folder and the file name itself. Let's combine them together using path.combine. Let's store this combined path in a variable of type string. I'm going to call this variable file path. Now, to copy the uploaded file to the images folder, we are going to use this copy-to method provided by this iFormFile interface. Remember, the photo property on our model object is of type iFormFile, and this property receives the uploaded file. This means on our model object, on this photo property, we can use this copy-to method to copy the uploaded file to the images folder. Notice on the incoming model object, we have photo property, and on this property, we have copy-to method. We need a new file stream to copy the contents of the uploaded file. So let's create a new file stream, and the file stream itself needs the path to the file, and we have the path to the file in this variable. So let's pass this variable to the file stream constructor, and then we want this file to be created on the server. So let's set the file mode to create. At this point, we have the uploaded employee photo copied into the images folder on our server. Now we need to create a new employee object and then copy the employee related properties from the incoming model object into this new employee object. Name equals model.name. Email equals model.email. Department equals model.department. And finally, photo path equals, we have the photo path present in this variable unique file name. At this point, we want to save this new employee object in the underlying employees database table. For that, we're going to use this injected iEmployee repository. On the repository, we have add method. To that, let's pass the employee object. After the employee is successfully saved to the database table, we want to redirect the user to the details section so we could see the details of that newly added employee. So let's uncomment this line. Remember, after Entity Framework inserts a new row for this new employee object in the underlying employees table, it takes the ID column generated identity value and automatically updates the ID property on our employee object. We are then passing that ID value to the details section so we could see the details of that newly added employee. Let's fill out the details of the new employee that we want to add. Click the Browse button. Let's select this photo, david.png, and then click the Create button. There we go. Our new employee is created and we are redirected to the details view, and we see the details of the new employee that we have just created. But we still see the old image. We don't see the image that we have uploaded. First, let's open the images folder in File Explorer. Notice we have the image that we have just uploaded. We see a grid, an underscore, and then the name of the file, david.png. But this details view does not display that uploaded image. That's because we have hard-coded the image source element to always display no image.jpg. So let's change the code in our details view. Let's go to the views folder and open details view. Notice the source attribute of our image element is hard-coded to no image.jpg. We want to dynamically set the source attribute. For that, I'm going to create a variable. Let's name the variable photopath. All our employee photos are in the images folder, and the images folder is in www.root folder. To get to the root folder, we use tilde. In that, we have our images folder. To that, we want to append the name of the image. To get the name of the image, we can use the model object. To get to the model object, we use @model. And on that, we have employee property, and on the employee property, we have photopath. What if an employee does not have this photopath property set? If we look at the existing data, notice for the two existing employees, Mary and John, the photopath property is null. It's only set for this new employee, David, that we have just created. So if the photopath property is null, we want to display no image.jpg. This expression in the brackets is evaluated first. If the photopath property is not null, then that value is used. If it is null, then no image.jpg is used. So instead of hard coding the source attribute always to no image.jpg, let's use the value that we have in this variable photopath. We have the same issue in our index view as well. Notice even here the source attribute is hard-coded to no image.jpg. The change is going to be very similar to what we already have in our details view. So let's make a copy of this line, paste it, and then change the bits that are required. The model for this view is IEnumerable of employee objects. We are using the for each loop here to loop through each employee object we have in the model. To check the photopath property of each employee object, we want to use this loop variable employee. Finally, let's use this variable photopath as the value for the source attribute. Notice now when I reload the page, we don't see any image. To get this working, use ASP-append version attribute on the image element on our details view. Notice now when we reload the page, we see the image as expected. We are using image tag helper here, which provides cache busting service. If you're new to image tag helper, please check out part 37 of our ASP.NET Core tutorial. Now, when we navigate to the list view, notice the images have different heights and widths. To set all these images to the same height and width, I'm going to include a custom CSS class. So let's open our site.css file. Our site.css file is in the CSS folder. I'm going to name the CSS class image thumbnail. Set height to 200 pixels. Width to auto. Now let's use the CSS class on the image element in our index view. Now hard reload the page by pressing Ctrl+Shift+R. Notice all the images have the same height and width now. At this point, let's create another new employee. Fill the details of the new employee. Let's select Sarah.png. Click Create. There we go. We have our new employee created. We see all the employee details, including the photo that we uploaded. Now let's navigate to the list view. Notice all the 4 employees are in this one row. If we add another new employee, that employee will also be placed in this one row, further squeezing these thumbnails. What we want to do is include a maximum of 3 thumbnails in a given row. There are several ways to do this. In the interest of time, I'm going to take the quickest and easiest approach. On this bootstrap card div, I'm going to include this custom style. I'm setting the minimum width to 18 rem and maximum width to 30.5%. Let's save our changes and take one final look at the browser. Notice now when we reload the page, we see a maximum of 3 thumbnails per row. Now let's create another new employee. This time I'm not going to select any image for this employee. Let's click Create. Notice the employee is created and it is using the default noimage.jpg. If we navigate to the list view, we see our new employee here, and even on the list view it's using noimage.jpg. If we refresh the data that we have in our employees table, notice we see all the employees. Both David and Sarah have a photo. We created Ben without uploading a photo, so the photo path property is null. That's it in this video. Thank you for listening.